Hello and welcome to Class Time, your daily classroom for CSEC and CAPE students. This time around, we'll be concentrating solely on math and English. We'll be running only 1 hour each morning, so make sure you are on time. You can watch this lesson in real time on Television Jamaica's YouTube channel or One Spot Media. Send in your questions to Television Jamaica's Facebook page or Instagram at television_Jamaica, or use the hashtag TVJClassTime. This week is a revision week, so in today's lesson, we'll be looking at CSEC Mathematics, Revision of Algebra. I am Tamika Lodge-Fenton. Let us begin. So, another look at algebra. Purpose of algebra. Algebra teaches you to follow a logical path to solve a problem. Algebra helps you identify patterns and help make useful generalization. So those are just little things about algebra. Let us look at some important points in algebra. First point, term. A term is either a single number or a variable, or numbers and variables multiplied together. So that's one way in which we could define the term. No, we could also say it is any collection of letters and or numbers that are not separated by a plus or a minus sign. Then we have an expression. An expression is a term or a group of terms. So remember now, so a term can also be seen as an expression. All right. Like terms. These are terms that contain the same combination of letters where the powers, or what we call indices, index or exponent, of the letters are the same, but the numbers can be different. Now, simplify. What does this mean? When someone says simplify an expression, simplify, it means to reduce in a simpler form by factoring of common factors, regrouping of terms of the same variable, etc. We'll look at it some more as we continue the lesson. All right, so let us look at a few examples of each thing that we just looked at. So we have, the first thing we had looked at were terms. So you have 5t is a term all by itself, 3u and z. So a term may have a number or it just may have the variable. Then you have like terms. Let's look at those. So we have 5c, 4c, c. Those all have things in common. It has the same variable, so they're called like terms. Then you have unlike terms. Let's look at that. We have 5x, 15ab, 3y, 4z. None of these terms have similar variables. They're all different. All right, so they're unlike terms. Now let's look at expressions. You have 2b is an expression all by itself. Then you have an expression with two terms, which would be 5x plus 15yx. Then we have another expression with also two terms. That is 3a subtract 4b. Great. All right, guys, so let's look at algebraic term. Now we have 4n squared. 4n squared, let's look at what each part of this algebraic term means, or let's talk about it a little. So we know this is an algebraic term. What does the 4 mean? Or let's talk about the 4. The 4 is a number at the front and it's called the coefficient. Remember that. The number at the front, before you look at the variable, it is called the coefficient. Then you have the n, is the letter part and it's called the pronumeral or the variable. Then you have the 2, which is a superscript number, and it is called an index or indice or power or exponent. You see how many words you can use to describe that 2 over there? All right. Now let's look at expressions versus equations. What do you think this is? I hope you did say it is an expression. It is an algebraic expression. Has more than one term in this instance, but no equal sign. So it is an expression. Then you have here, I should have probably said it, it is 4n squared plus 7 is an algebraic expression. Now you have 4n squared plus 7 equal 11. This is an equation. It has an equal sign. It is a complete mathematical sentence. So it is different from an expression. And we'll look at it as we go through. So let us do some basic algebra now. All right. Let us recall what 7a means. What does 7a mean, guys? So 7a simply means 7 multiplied by a. So when you see the coefficient 7 next to a, it means that you're multiplying. All right. Now, if we were to replace that a with a plus b, we now would have 7, open bracket, a plus b. Why? Because that means we are substituting wherever you see a in that term or expression with a plus b. And that's how we pretty much look at simple things in algebra. All right. So what can we do here now? We can use what is known as the distributive law. So 7 on the outside of the bracket must be used on both the a and the b inside of the bracket. So let's look at what that is. So what we're saying is 7 must be multiplied by the a, added to b, which is also multiplied by the 7. So we have 7a plus 7b. And simplifying gives us, as you can see there, now we can always factor out the 7 if we need to, but of course we just distributed the 7. So that's fine. Let's look at another activity. So we're going to simplify, remember the term simplify, to reduce to its simplest form. We're going to use the distributive law where the 5 is concerned and distribute the 5, multiply the 5 by both the a, the 2m, and the 3, and simplify. All right, let's go through. So we have 5 multiplied by 2m will give us, we'll figure it out, and 5 multiplied by 3, as you can see here, you have the 15m to add and the plus 2 there. Now, what do we do here after we open up the bracket, remove the bracket, or distribute 5 throughout that bracket? We will simplify. We'll combine like terms. So 5m, 10m plus 10 plus 15m plus 2. We're going to regroup them. And you realize that it's easier if you work by putting your like terms together. It's smoother on your eyes and it's easier to make the calculations. So 10m plus 15m gives us 25m, and then you have 10 plus 2 gives us 12. Now, is there anything else we can do with this? There are no factors shared between these two terms. 25m plus 12 have no common factor, so this expression is in its simplest form. And we just stop there. All right. So let us try another one. Simplify negative 4, open bracket, 5 plus n, close bracket, subtract 8n, using the same distributive law. So as you can see here, we're distributing negative 4 throughout that bracket there. What does that look like? All right. So it simply means the negative 4 must be used to multiply both terms in the bracket. And that would look like, all right. All right, removing the brackets, we have negative 4 multiplied by 5 plus negative 4 multiplied by n. And of course, now negative 4 multiplied by 5 gives us negative 20. Negative 4 multiplied by n gives us negative n. Now, I deliberately put the plus and the negative n there because initially there was an addition sign and a lot of times we miss the point here. Now, there is a positive or plus and a negative sign facing each other. What happens when that happens? What do we do? Well, when you multiply or when a negative and a positive, this is now going to be a negative. So what we're saying, so we'll write it back now. Negative 20, subtract 4n, subtract 8n. All right, so we are grouping like terms. All the n's are together and there's only one constant there, 120, one constant, so that's fine. Simplifying gives us negative n, negative 4n, and negative 8n will be combined to give us negative 12n. So our simplified expression now becomes negative 20, negative 12n. Is there anything common? Yes. There are common factors with negative 20 and negative 12n. So we can factorize negative 2, giving us 10 from the negative 20. What do I mean factorize? 2 divided into negative 20 gives me, or negative 2 divided into negative 20 gives me 10. Negative 2 divided into negative 12n gives me positive 6n. Remember, whenever you factorize out a term, whenever you carry out the calculation, whenever you undo the factorization, so if I were to multiply what is the negative 2 by whatever is in the bracket, I must get back what I started with. Let's just run through that. Negative 2 multiplied by 10 will give me negative 20. Negative 2 multiplied by positive 6n will give me negative 12n. All right. All right, we'll be using algebra to solve this item. So clearly remember we're reviewing algebra, and let us look at this particular question here. So angles in a quadrilateral add up to 360 degrees. And we have a question that says the angles within a quadrilateral are represented by 12x plus 15 and 17x minus 10 plus x plus 50, and the other angle is 15x plus 35. Let us look at that on the board before we do the calculation. What is a quadrilateral? A quadrilateral is a four-sided figure, a four-sided polygon. All right? Now, clearly I don't think this is a very good drawing of the quadrilateral we have, because if you look at it, all right, the angles, there's no two angles that are alike, represented by those algebraic expressions. So I need to be careful how I draw my quadrilateral. So I'm just going to draw it so that all the angles look all right, great. So I'm going to have 12x plus 15. I'm just trying for you to understand what the question is saying and how algebra can be used to solve various questions. So we have one angle is 17x, subtract 10, another angle is 12x plus 15, and then we have x plus 50, and then the last angle is represented by the expression 15x plus 35. So they have used 4 different expressions. Guys, I don't know how I expected you to see that. Let me just make that much bigger for you to see exactly what I'm saying. I do apologize. So 12x plus 15, then you have 17x subtract 10, and you have x plus 50, and then the last angle represented by the expression 15x plus 35. So let's look at a few points. All the angles within this quadrilateral are represented by an expression. The expressions, however, have the same unknown, so we can use them and figure out some stuff. So there's some information that you need to know about quadrilaterals. The angles within a quadrilateral add up to 360 degrees. What does that mean? That means if I add this expression to this, to this, to this, they should all give us 360 degrees. And that makes it possible to determine not only each angle eventually, but we can find a value that will satisfy x in this equation here. All right, so let's look at that. So we'd have to add them, as you can see here. Let's move back to the screen. You have 12x plus 15, and it's all lined up, equaling to 360. All right, we're going to remove the bracket, and we're going to group like terms. So all the x terms are placed together, and all the constant are placed together. So let's look at that. 12x plus 17x plus x plus 15x. Then you have plus 15, subtract 10, plus 50, plus 35. They all equal 360. All right, when you combine the x terms, you get 45x. Combine the constants, you would have positive 90, and this equals to 360. Then we can work it out. So what is happening to the x over here? It's being multiplied by 45, and also 90 was being added. The opposite of adding 90 is to subtract it. So I've subtracted the 90 from here. I have to subtract it from the other side of my equation. Whenever you're working with algebra or equation, whatever is done to the right side must be done to the left side, vice versa. So we subtract 90 from both sides, and we end up with 45x equal 270. That's not what we want. We want to figure out what is the value for x. So x is being multiplied by 45. The opposite of multiplication is division. So we'll divide both sides by 45 to get the value for x. So let's look. So 45x divided by 45 gives us x. 270 divided by 45 gives us 6. What does that tell us? That for this particular set of expressions and equation, the value where x is 6 will satisfy it. And of course, you could substitute the x back into any of those or all four of them and calculate each angle and then add them up, and you would get 360 degrees for the entire quadrilateral, totaling angles. All right, guys, so that's your first question up. Next question. Hope you can see it clearly. So let's write this on the board, and let's work through it, and then we go back to the screen. So we have, if 5, open bracket, 2x subtract 1 equals 35. So we have 5, 2x, subtract 1, equal 35. So this is an actual CSEC question, guys, and you are asked here to apply the concept of algebra. What do we do? So it wants you to find out the value for x. So we know that we can distribute 5 through the two terms that are there. 5 multiplied by 2x gives us 10x. 5 multiplied by negative 1 will give us negative 5 equal 35. Whenever we're working with algebra, the key is to find the unknown, and we're going to undo what was done to the variable. So the last thing that was done, 5 was subtracted. We're going to add back that 5. And if I add it back to the left side, I must also add it to my right side. Negative 5 plus 5, that will give us 0. We'll call that a 0 pair. Your 10x is left. 35 plus 5 gives me 40. What is happening to the variable here? It's been multiplied by 10. What is the opposite of multiplication? Division. So let's undo that multiplication by dividing 10x by 10. I said it already, but I'll say it again. You must carry out the same operation on both sides of your equation. 10 divided into 10x gives me x. 40 divided by 10 gives me 4. So for this equation, what did I do? Okay, good. All right. So as you can see, we pretty much did this on the board. It is just for you to see. So our value for x that satisfies this equation is 4. Let's sub it back in and see what happens. 2 times 4 is 8. 8 subtract subtract 1 gives us what? 7. 7 times 5 is 35. Great. All right. And there you go. All right. Awesome stuff. I think I went past some stuff. Let's go back a little. All right. So that. Perfect. All right. Algebra does help us to solve many problems in real life, guys. So let us look at another way in which we can apply our algebra concepts. We're going to look at algebraic fractions. Algebraic fractions looks like a regular fraction with algebraic terms or expressions as the numerator or denominator. So I hope you like fractions because you will be working with algebraic fractions as you complete your CSEC years. All right, so we're going to simplify today. So we have b squared plus 3b all over b. So we have a term in our denominator, and we have, well, it is an expression as well. So we have two separate expressions in our numerator and our denominator. What's the first thing we'll do? We'll factor out anything that's common. All right, so let us look. If you look at b squared plus 3b, is there anything common to you? Yes, man, everybody can see that the b is common to both terms in the first expression. So let us factor that out. So if we were to factorize b, we'd have, so we divide b squared by b, we'd have b left. And if we were to divide 3b by b, we'd have 3 left. Did I say 3? I feel like I'm saying 3 twice. Right. And then, of course, you will have to replace your denominator. All right? So we factor that out. Now, what can we do? Just like any other fraction, we can also divide something in the numerator. So we're factoring from the numerator and the denominator now. So b is common to both numerator and denominator. We can factor it out, leaving us with b plus 3. So that would have been, or, where you gone? Huh? There you are. So we have b plus 3 would have been our working out or simplifying or simplified version of our original expression. All right, guys, let's look at, before we even go into any more, just remember that algebra is easy. Algebra, just take some time to look at it and you'll get it. We're going to take a quick break. We'll be back with more mathematics in a few.
Hi there, I'm Simon Preston from TVJ. Thank you very much for watching our YouTube channel. To see our latest videos and also to see live events, click here. To see our full videos on onespotmedia.com, click here. Thank you very much for watching.
Welcome back to Class Time, your daily classroom for CSEC and CAPE subjects. If you're just joining us, we're doing a revision of algebra. Let's get right back to the lesson. So before we left for the break, we were looking at algebraic fractions. And now that we're back, we're going to do another one, simplifying algebraic fractions. And as said before, an algebraic fraction is simply, it looks like a regular fraction. It has a numerator and a denominator. However, in this one, you will have algebraic terms or what we call expressions, either in the numerator or the denominator, or even both, like this instance. So the algebraic fraction we have here is 5a all over 2a subtract ab squared. What are we going to do here to simplify? So when we simplify, we look for common factors. So since there's only one term in the numerator, we can't factor out anything there. However, the expression in the denominator has two terms. Are there anything that is common to both the first term and the second term? That's the question you ask yourself. And what do you think? Yes, there are. So if we look here, I would have now factored out the common term or the common factor within the denominator. A is common to both 2a and ab squared. When factored out, that means I've now divided both terms by a. 2a divided by a gives me 2. Negative ab squared divided by a gives me negative b squared. So as you can see, now my new algebraic fraction will look like 5a over a, open bracket, 2, subtract b squared, close bracket. Now, looking at your numerator and denominator, you can definitely see, because I've done it for you, I've highlighted the common things. So a is both common to the numerator and the denominator. What can we do here? Yes, we can further factorize. So a divided into a goes one time. So now we have a or 5 all over 2 subtract b squared. So this is your simplified algebraic fraction from where we started. All right, guys? So the fractions are, just to note, the fractions are not of the same whole in this particular question. I probably should have looked at the question first. So let's look at it before we even discuss this. So we have 1 all over 5x plus 2, or 1 5x plus 2 3x, and those are our two fractions. Now the denominator for the first fraction is 5x, the denominator for the second fraction is 3x. Now if you remember working with fractions, you realize that if the denominator tells you what? Yes, man, it tells you how the fraction has been divided. So if they're different, even in algebraic terms, it tells you that you can't just operate with them. That's what I was trying to capture here. If the fractions are not of the same whole, we must first represent them from the same whole. So let's look at that. So we're going to find the lowest common multiple for 5x and 3x. All right? And that would have been 15x. Now, you know how you look at factors. So let's just look at the board for a little bit before we continue that. So if you were to have 5x and you have 3x, what is the first, did I say factors? I meant multiples. The first multiple for 5x would be 5x. That means 5x can go into itself, clearly. What's the next one? You would have 10x, then 15x, right? And then we could have 20x. So 5x can be divided into 5x one time, divided into 10x two times, 15x three times, and you get it. So let us look at 3x. What are the factors for 3? What are the multiples? What is wrong with me? The multiples of 3x would be 3x, 6x, and then we have what? 9x. Then we have, boy, these x don't look too right. All right, then we have 12, man, I can't. 12 x, and then we have 15x. So what we're saying when I talk about the lowest multiple, it means that when you look at the multiples of 5x and 3x, the first place where they have the same multiple is 15x. Hence why we can use that for our new denominator. All right? So, there we go. So there is, similar to how you work with when you're working regular fractions, I'm going to now change my 5x to 15x. What do I do to change it? How do I change it? 15x divided by 5x is 3. So I would have to multiply 5x by 3 to get it to 15x. Therefore, I'll have to also do it for the numerator. And as you can see right here, so 1 multiplied by 3 would give me the numerator value now that I have changed my denominator. And same thing, this should have been 15x, guys. This 3x here is 15x. So you'll multiply the 5 by the 2 by 5 here. So now we'd have, so this being 15x, you would have 3 plus 10 gives us 15x as your answer when you're adding 1, 5x plus 2, 3x. All right, and your choice over there would have been D. This is one of your multiple choice items on the CSEC paper. Let us look at another one. Let us go to the board. Just give me a little while to take this off. So our question says if P fifth, oh Lord, P fifth equal 20. What is P? All right, so let's look at that on the board. P, so where our whole is divided into 5s, and as you can see here, there's no algebraic, there's no variable in this denominator, and it's quite fine. It is still an algebraic fraction. Let's change that 2 to a better looking 2 so that I don't confuse anyone. All right. All right. So let us look at this now. P. So we're trying to figure out what is P if this is the equation given. And remember when we started the lesson, we talk about an expression. So this expression here equals this expression here. And we have an equation. Remember, equation has an equal sign. Let's work this out. So we have P. What is happening to the P over here? It's being divided by 5. What is the opposite of division? Correct. It is the opposite of division, is multiplication. So I'm going to undo what was done to it. So I'm going to multiply by 5. I must carry out the same operation on both sides. 5 divided by 5 gives me 1. So I end up with P only. And 20 multiplied by 5 gives me 100. Okay? But that's not what they asked you for, is it? So when you look on the paper, you would have realized that this is where they wanted you to stop. They want you to come up with the expression that tells you how to find P. So your choice would have been choice D. All right? And as you can see, it's right there. All right, so the next one. So we're going to do a little algebraic thinking here, guys. So let's read this together. When 6 is added to a number, and the sum is divided by 3, the result is 4. This statement, written in a mathematical symbols, is. So let's just pretty much walk through what is being done here. It says, when 6 is added to a number, so we have 6, and you add it to a number. Did they tell you the number? No. So guess what happened? You can use any variable to express that number. So 6 is added to a number. I use D. All right? Good. Then it says what? Then the sum is divided by 3. You all know sum, you're talking about addition. However, you can't add 6 to D because you don't know the value of D. So you leave it as is and you divide by 3. Excellent. Is that it? It says the result is 4. Result means that we would have equal it to 4. So now we have 6 plus D divided by 3 equal 4. It's that simple, guys. Now look at your options there for number 31, one of your multiple choice item. Do you see a D? No. But the letter really doesn't matter. So all you need to look is they all have X, so you're replacing the D with an X. And your option for this one would be A, correct? Great. So the letter, the variable doesn't matter. Any letter can be used to represent the unknown. That's all that you need to know. All right, great. We're going to look at another thing as it relates to algebra, laws of indices. So let us look at that. Let us review a little bit. D raised to the power of 4, or we can say, yes, D raised to the power of 4. I don't know what to call that. What does that mean? It means that you're multiplying D by itself 4 times. All right, so we have D multiplied by D, multiplied by D, multiplied by D. That's what it means. Now, there are parts of the whole expression that is important to understand. D is the base, while 4 is the index, the indice, the power, or the exponent. So there are several words in which you can use to describe that 4. All right, now let's look at another one. A raised to the 3rd power, or A cubed, which means A multiplied by itself 3 times. All right, and as you can see here, the base is A, and the 3 is the power or exponent. All right, let's do some things. Let us look at the bases and powers of the indices and see if we can simplify without expanding. All right? So what we did a while ago before we move on to the next thing, we were looking at the expanded, when I said D to the 4th power, we expanded it and wrote it out. D multiplied by D multiplied by D multiplied by D. So what we're being asked to do is to work this out without expanding. So A raised to the 6th power multiplied by A to the 7th power gives us A 6 plus 7. So in this instance, when the base is the same, we can just add the exponents. Okay? So you'd add the 6 and the 7, giving you 13. So that would be the simplified way, but without expansion. All right. So our first question here, guys. If X equals -2, Y equals 3, T is equal to 2, then X over Y, all raised to the T power. What is the value for that? And let us look at it on the board before we run through it on the screen, just to ensure that we all are following and I haven't left anyone behind. All right, so they gave us some values for the variables. And I'm just going to write them here. So you have X is equal to -2, Y is equal to 3, and T has a value of 2. And they're asking you to determine what is X, Y, all raised to the T power. T power, okay. So we're going to substitute wherever we see X for -2. Let's do that. So we have -2 up top in the numerator, and for the Y we have 3, that's your denominator, and they're all raised to the 2nd power. What does that mean? It means that both the numerator and the denominator is being raised to the power. So let's open that up a little. You see, I'm not trying to write any equal sign on the board because we're not working with a definite equation. We're just evaluating this expression here. So we now have -2 raised to the 2nd power over 3 raised to the 2nd power. That's what it means. So -2 multiplied by -2, it will give us +4. We do not write the plus sign there. Conventionally, we do not, but if it makes you comfortable, feel free. And then 3 multiplied by 3 gives us 9. And that's it. So your option would have been B. B would have been your correct option for this particular item. And I would have done it here. Whoops. Sorry about that, guys. All right, let's look at it again. All right. So we would have multiplied there. I would have expanded it for you, and your option is still B. All right, so another question here. if a is 3 and ab equals 6, then a squared subtract b squared equals, all right, so what are we asked to do here again? We're asked to use the laws of indices to help us work this problem out. We're also being asked to substitute and give us a value for the expression a squared subtract b squared. So we're going to do that together. All right, so what's the first thing that's there? We have, let us see. So the first thing that you may want to do is to go a squared subtract b squared. And we want to say, what's the value for a? 3. So you can substitute that. What's the value for b? Look at that, they didn't give you the value for b. So you have to stop right there. And you're going to look at what they gave you. So they said ab is equal to 6. Therefore, we can use that equation to solve for b. That's what we're going to do. So we do have the value for a, which is 3. So let's substitute 3 into the equation. So we now have 3b equals 6. How many unknown do we have in this equation? We only have one, b, so we can solve for it. What is being done to b? It's being multiplied by 3. The opposite of multiplication is division, and we must do it we must carry out that operation on both sides. So 3 into 3, 1. So we end up with b. 6 divided by 3 gives me 2. So the value of b that satisfies this equation is 2. So now we can go ahead and substitute b with 2. 3 squared, that's 3 multiplied by 3 gives me 9. Subtract 2 multiplied by 2 gives me 4. What is that? 9 subtract 4 gives me 5. So the answer is C, option C. All right, so we would have substituted it, and we'd have done that, and pretty much everything that we just did on the board. 9 subtract. Did I put subtract? Guys, you couldn't tell me that I had. Let me see what I had there. Did the question have a subtract or a addition? I've been working with subtraction, and then I added it in the end. It's subtraction. So you see, it's a good thing we did it on the board, because I added it. Oh, yes, I did. So let me see. Let us look at this a little bit, because I don't know why I would add it there. Just let's look at the question, the original question. All right, so it would have been, if I were to sub, it's 2, and I would have done that. So it would have been 4, subtract that 5. Right, but you see how, okay. So if you would substitute the 2, and then you would have calculated that 2 multiplied by negative 2 squared would have been positive 4. Right? It would have been positive 4 if I squared negative 2. So I would have added, which would have given me 13. So you see what happened there? I did not pay attention to my negative sign when I was squaring it. So I just squared it without paying attention to the sign in front of the number, which you guys have to be careful, because look at that. I made a blunder there. So your option is 13. So you would have squared negative 2, which would have given me positive 4. So let's look at it on the screen. There you go. You'd have squared it there, and you would have gotten 13. All right, guys, so your option there would have been D. Let us move on to the next question. So we are at solve the simultaneous equation here. And you have 2x plus y equal 3, 5x minus 2y equal 12. So guess what happened? I'm just going to leave you there to think about this while we take a short break, because, you know, I want you to tell me when we come back how we solve this question. All right? When we come back, we will wrap things up. Have a good one.
Hi there, I'm Simon Preston from TVJ. Thank you very much for watching our YouTube channel. To see our latest videos and also to see live events, click here. To see our full videos on onespotmedia.com, click here. Thank you very much for watching.
All right, welcome back everyone. Just before we go into that simultaneous question that we left you with, let us look at something here on the board. We have negative b squared versus bracket negative b squared, close bracket, squared. So let us look. If the value of b is 5, let us see what they both work out to be. So I have negative 5 squared. That gives me what? So we have negative 5 squared gives me positive 25. Right? Is that right? All right. And then now we have 5 here again, negative 5 all squared. Why don't you know? Let's see. Let's change this here. There you go. So, negative 5 squared, there. So we have, all right, negative 5 squared is 5, negative 5 multiplied by negative 5 Or is it 5 squared and then you put the negative? So it is 5 times 5 gives us 25, and it is negative 25 here. Then you have, so I was correct the first time. So we have negative 5 all squared. So now negative 5 multiplied by negative 5 will give us a positive 25. So there is a difference. Why are we back here? Because the previous question that we did, the answer was 5. It was 5, yes. 9 subtract 4 was 5. Because of how the question was, it was A squared subtract B squared. That means I would have squared it. So it would have been 3 squared subtract 2 squared. 3 3s, 9 subtract 4, which would give us 5 as the answer. So there is a difference when the B has the negative sign in front of it versus when it is negative B all squared. Just remember that, guys. So when it is like that, you square the number and you keep the sign. When it is like this, you would have squared the negative value. All right? So it is negative 5 all squared. Negative 5 multiplied by negative 5 gives me a positive. While here, 5 multiplied by itself gives me 25, but I have a negative sign, which I must carry down with it. All right, or I must place back where it is. All right, guys, let us look at the simultaneous equations. And today we'll be solving by substituting. All right, what do we mean by that? So the first thing when we're substituting, we need to find a value for one of our unknown. Because what you should know by now when working with algebra, if there are more than one variables within an equation, you can't solve unless you have a way to express one of those variable in terms of the other. So that's what we do with simultaneous equation here. So we can, for the 2x plus y equal 3, we can rewrite it. We can transpose, making y the subject of that particular equation. So we can write an expression in terms of y, where you have the expression is in terms of x, I should say. So y here is equal to 3 subtract 2x. So now what can we do? We can substitute the value of y for 3 minus 2x. And as you can see, I would have done it here. So 5x subtract y, which is now substituted by 3 subtract 2x, equal 12. And I can now use the law of distribution to remove those brackets. Negative 2 multiplied by 3 gives me negative 6. Negative 2 multiplied by 2x gives me positive 4x. So now I would want to group like terms, giving me 5x plus 4x subtract 6 equal 12. Let us carry out the calculations, giving me 5x plus 4x gives me 9x, subtract 6. And I went along here, I was trying to get you to see that I am undoing what was done to the x. So I am going to add back the 6 that was taken away from 9x. And you can see it here. I add it back to my right side as well, giving me 9x equal 18. I do not want the value for 9x. I want the value for x. And because of that, I'm going to undo what is done to the x here by dividing throughout by 9 to get the simplest form. And that will give me 9x divided by 9 leaves me with x. 18 divided by 9 gives me 2. So I now have a value for 2. For 2? Really? I now have a value for x. So now with the value for x, I can substitute into one of the equation. So if I were to substitute a value for x into this equation, which we would call our equation 1, 2x subtract y equal 3. Wherever I see x, I'm going to put 2. So we have 2 multiplied by 2 gives me 4 subtract y equal 3. I want to make y the subject of the formula, and I do just that by doing the opposite of what is being done to it. So 4 is being added, I subtract it, on both sides, giving me negative y equal negative 1. I do not want to find the value for negative y, so if I simply multiply throughout by negative 1, I will find the value for y without changing the value of the equation. All right, so that will give me y is equal to 1. All right, guys, so that is that. So when x is 2, y is 1, and these values for the unknown will satisfy the equations that we were working with. All right, so let us just quickly look at some of the things we did today. We have looked at some key terms in algebra. You should know by now you have terms, and you can have like terms and unlike terms. These are a few examples here. All right, so when it's like, they have the same variable. When it's unlike, they have different variables. An expression, this is an example of an expression 2d plus 4d. Also, 2d all by itself can be an expression. Please remember that. So then we have variable. The variable is the unknown value, usually denoted by letters, and the letter does not matter. What is a coefficient? The numerical value that is multiplying the variable. All right, then we have the constant, a term that has a value that cannot be changed. Remember that. All right, so we looked at the laws of indices and we looked at algebraic fractions. And when working with algebraic fractions, treat it like regular fractions. And this is just a summary of the laws of indices. Guys, thank you very much. That's all for today in this lesson. We revised algebra. You can catch a repeat of all of today's lesson on JNN at 4 p.m. Highlights of the week's programs are also on Saturday between 1 and 4 p.m. on TVJ and on video on demand on One Spot Media. Remember our news time, our new times, Monday and Friday, 9 a.m. to 10 a.m. And also, don't forget, the school time, Channel 24-hour learning is back on One Spot Media. Until tomorrow, keep safe.
Hi there, I'm Simon Preston from TVJ. Thank you very much for watching our YouTube channel. To see our latest videos and also to see live events, click here. To see our full videos on onespotmedia.com, click here. Thank you very much for watching.